Hello, my name is Charles Porter and this is 6.3 Numerical Model. So what is the numerical model? The numerical model is made up of three main sections, made up of projectile motion, angular motion and linear motion. So under linear motion there's three main sections. So we have scales and vectors and we also Newton's laws, and we also have centre of mass and stability. We'll talk about them a little later on. So, the factors of linear motion. Here we have acceleration, velocity, speed, displacement, and distance. So what is acceleration? So acceleration is basically the rate of change. So this is depending on velocity and speed. So if we had velocity, it would be the acceleration between one speed and another, whereas speed we could have it from, say, standing still to the rate of change until their velocity. And then we move on to so what is velocity and speed basically? So velocity is how quickly something can move in a direction, whereas speed is how quickly that thing can actually move. So velocity is mainly the direction, and speed is just the actual how quickly that object can move. Now moving on to displacement and distance. So they're sort of alike, but they're not. So distance is covered in all directions, whereas displacement is basically from A to B. So if we took a marathon, for example, the distance would be the distance covered around all directions. So a marathon is normally deemed as 24 miles. So that would be the distance, whereas the displacement would be the distance between the start line and the finish line in the shortest direction possible. So now moving on to scales and vectors of linear motion. Um, so we have both scalar and vector quantities. So scalar is something that has a magnitude, so i.e. something that is big or fast, and then vector is sort of the same, but it's in that direction, so how big or how fast the thing is moving in the direction. So here we have, there's three quantities under each. So we have DAS and we have DAV. So DAS stands for distance, acceleration, and speed, whereas DAV stands for displacement, acceleration in a given direction, and velocity. So once again, we have distance and displacement as they're both different for scalar and vector. So now we've gone to Newton's laws. So as you should probably be aware, there's three main laws. So the first one is law of inertia, the second one is acceleration, and the third one is action and reaction. So let's start off with law of inertia. So this is basically where objects remain still at a constant speed unless an unbalanced force acts on it. So and force, so basically if someone was to be running, an athlete was to be running at a constant speed, and then somehow they slow down due to maybe wind conditions, that would be the unbalanced force. So that would then slow them down, because there'll be more of a force on one side than the other. Then we have acceleration. So this is basically described as force equals mass times acceleration. So that's what force is. So it's yeah, and then moving on to action and reaction. Here we have when a force is exerted onto an object which then collides with another, the force will equally transfer, sending one object in another direction. So basically, if we had tennis for an example, the force acting on the object would be the tennis racket. Uh, so that would be the action. That would be the action force. So the racket hitting the ball would be the action force, and then the force acting on the ball would be the reaction force. So the ball moving away from the racket would be the reaction force. So here, moving on to center of mass and stability. So what is center of mass? So com, or center of mass, is the place at which the body is stable in all directions. So basically, if someone was to be standing still, the center of mass would be around their belly button, because that's the middle of their body. Um, And it can also be outside of the body. So here, for example, the center of mass is nearly outside the body, but if they were to move the shape of their person, like they've done here, their center of mass would change, as there may be more weight on one side of the body compared to the other. So stability relies on the center of mass. So having the center of mass lower to the ground, creates lot more stability. So also holding the line of gravity within the base of support. So the line of gravity, if that was straight through the middle of the person, they would have a better center of mass, and they would also be able to have better stability. Also having a larger base of support. And that also relies, sort of links with having more areas of contact. So basically, here we have a foot. This might not be a large base of support. If she had, say for example, if she was sitting down, that would be a lot more stable, as there's a larger base of support, because um, there's more. Um, and yeah, so having more areas of contact as well. So if someone was to go on a handstand, but, or maybe a headstand, if we compared them both, the handstand would be more unstable, as there's only 2 points of contact with the hands, whereas the headstand would be more stable, as they're using the head and the two hands. So why is instability useful then in gymnastics? Normally people look at gymnastics as you need to be quite stable, but you need instability as well. So here, um, we have she's trying to cause instability, and she's moving her body weight over to one side. It's therefore moving the center of mass, creating a toppling effect to the left. So, this is basically, it's creating instability, because normally stability, she would be standing still and she'd be very stable, whereas as the center of mass is moved, this will cause her whole body to move to the left, which is what she's doing, and then creating that toppling effect. So moving on to the method of collecting data. Um, so here we have camera and equipment, we have data collecting and presentation, and we have research. So these are three main areas of which you need to have while collecting data, or before collecting data even. Starting off with research. So with research, you want to research what areas need improving on. So this could be for a team or individual person. So basically, what areas they're hoping to improve on and what areas they should be improving on. Say, for example, if I was playing football and I was a striker and I was missing quite constantly at close range, but I was scoring from long range, I'd want to try and improve on close range shooting. If we relate it to basketball and rebounding, which is what we're doing at the moment, we'd want to see if our rebounding's up to full potential. If not, then that's the area we can improve on. And basically how to improve. So like I said, team or individually. Um, Related to basketball, so we want to look at professionals and see how they basically rebound, and maybe copy their technique. So then yeah, so basketball statistics as well. So looking at different statistics in the game and comparing them from a professional level to a standard level. So moving on from those basketball statistics. So here we have the Chicago Red Bulls. So this is an NBA basketball team. So these are basically stats from the NBA website. And so Chicago Bulls, they're rated second in the standings, and this can be due from their rebounds. So they have the highest percent of defensive rebounds, making them a really solid team, making them not concede as much points. So then moving on to more statistics. So here we have the relationship between height and rebounding. So basically, what I'm showing you is the stats and statistics that you would take on board before collecting data, so you know what to expect and you know what to find out. So here you can see a positive correlation here. The line of best fit is going upwards. And here you can clearly see that small people down here, smaller people down here, they have a lower rebounding efficiency, whereas we have the taller people up here have a lot higher rebounding efficiency. So, methods of collecting data then. So, start off with, you need to start out with a PARQ. This is obviously done before an activity, so PARQ is quite physical activity readiness questionnaire. Basically, a client fills this out to tell the teacher or the coach what form they're on and their health and what stage they're at. Um, and also before, you take note of the independent, dependent, and control variables. So this is basically what you're going to change or what you're going to keep the same in the test, so that it makes the test fair. Obviously, you need a warm up just to prevent injury, and create better blood flow and warm the body up. And then we have equipment. So, for example, what we did with the force plates and the camera, with the basically testing our jump heights. So we need all the equipment in the right place, so ready to perform. So with actual collecting the data, so there's different things. So we have filming here. Basically, you want to film the whole thing on tape, so you know basically the method that the person's doing. So if they were to jump, you'd want to film their method and how they actually jump. So say if they use two arms to swing, or if they don't use any arms at all, you can maybe feed back to them on that, saying if it's a good or bad idea to swing your arms or not. Then we have camera angles, distance, and height. So basically, you want the camera at the right angle, and you want it at the right distance and the right height, basically to capture the full image of the person jumping and then landing, and then also seeing the angles at which their legs are. So you want to see, if we look at the picture here, side on would be a better angle, as you can see the angles of their legs from takeoff. Then we can also see the straightened legs in the air. Um, then moving on to shutter speed, focus, and frame rate. So these main things mainly give you a better image in detail. So you can look at them in more detail and see the angles of the legs and movement. And obviously focus, to getting the right camera lens fit for the job, so you know how good, how basically the angles of the person. And then the frame rate, capturing again better images. And we have frames per second, which is basically what frame rate is measured in, and they also capture things in better detail. So the higher amount of frames per second, the better detail will come out in the picture. We have shutter speeds, good and bad. So with shutter speeds, there is good and bad about it. Say, for example, if we had a football player and they were kicking the football, shutter speed can be good because you can you can take a picture and you can pause the person at the exact right moment. So if the shutter speeds were higher, there would you would see basically a picture sort of as if they're standing still. But if you had a lower shutter speed, you would see the actual movement of the person, um, and it would be a little bit glitched, but you can actually see the movement of the leg. So there's goods and bads about it. So camera positioning then. So with camera positioning, we have planes of motion, axes of rotation, um, and yeah, so planes of motion. So we have sagittal, frontal, and transverse, and axes of rotation. We have transverse, vertical, and sagittal. So sort of the same words apart from frontal. and vertical. So, planes of motion.